Mandal, Dean FET at Jadavpur University. He was the Vice President East of Indian Concrete Institute for 2022 to 2024. A pioneer in bacterial concrete, he holds Indian and US patents, has published 75 plus research papers, and actively contributes to BIS committees and various professional bodies. I welcome you on stage, sir, and I request you to lead the proceedings.
Hello. Good morning to all of you. We are now today starting our second day program, CCTS, Concrete Construction and Technology Solutions. Today we have, in this first technical session, there are two lectures are there, two presentations we can say. I call Sri Nilotpal Kaur to be present here. He's the first presenter, and he will give low carbon SSC with state-of-the-art dispersant polymers. And I also call Sri Bipin Kumar, please come here. He will be presenting on smart concrete and intelligent structures. Now let me introduce first Sri Nilotpal Kaur. Sri Nilotpal Kaur is the Managing Director of SICA, brings 37 years of passionate experience in construction chemicals and building materials. A hands-on sales and marketing leader, he has worked across South Asia, the Middle East, Asia, and the Pacific. Honored with the Industry Captain Award in 2023, he thrives on breaking the status quo and learning through real-world engagement. Regarding Sri Bipin Kumar, he is an IRAC officer and Chief Project Manager, Civil at Rail Vikas Nigam Limited, brings over 23 years of expertise in executing large-scale infrastructure projects across India, and IIT alumnus. He currently leads the Kolkata Metro and Kona Expressway projects, renowned for his innovation, leadership, and execution excellence. He has made significant contribution to the metro, tunnel, and expressway projects with a strong focus on safety, quality, and sustainability. Now, I request Sri Nilotpal Kaur to give a presentation on low carbon SSC with the state-of-the-art dispersant polymers. And after the presentation, we will take the question and answer sessions.
Thank you, Sharajda. He's my senior in Jadavpur University, 3 years senior, so more than professor, I respect him as a dada. Good morning to all of you. Today's topic is more about smart solutions and how concrete admixtures can actually change concrete from a 3D, which is dull, drab, and dreary, to very dashing, which is the fourth dimension of 4D. So it's more about high-rise construction. We are talking about projects from Burj Khalifa, where single-stage pumping has been done up to 600 plus meters, to even in India, 200 meters, 300 meters, where challenges of aggregates and cement have been overcome with these dispersant and novel polymers. So we talk about understanding concrete rheology. And just to give you an example what rheology is, if you have concrete in a batching plant from the transit mixer, you pour it on a wheelbarrow, if your scoop can go in very easily without breaking your arm, because we're talking about very, very easy mixes, that is rheology. So rheology is a comparison between water and honey. Water can flow easily, honey cannot flow easily. It will flow, it will creep. So that's the difference, very simple. Of course, there is rheometer, ICAR rheometer, and more complex technical instruments which are used for that, and we will show you a little bit of that, how that has also been used. Today, the drivers in construction, if you look at it, fast and easy construction, everybody wants to build faster. So in doing that, what happens is you compromise on many things sometimes. Especially, I think Professor Neville and Duff Abrams, if you are a fan of concrete technology, is all about water-cement ratio, or today water binder ratio, because there's a lot of supplementary cementitious materials being used. And the more you can use, the more your concrete is going to be durable, that we know. But it's all about the water binder ratio, which actually changes the coefficient of permeability of concrete by a factor of 20 if you don't take care of it. Then we talk about system solutions from basement to the roof, including waterproofing concrete. But if you don't make concrete well, then no matter what waterproofing system, because today people are selling warranty and guarantee. আমি আপনাকে 25 বছরের গ্যারান্টি দেব, but not about the system. And this is where the dimensional shift of the mind needs to happen. Otherwise, we are not going to be really creating intelligent structures. When we talk about green building, which is all about eco-efficiency, the first project to use 70% slag was a sewage lining project in Mumbai. It's called the Bandra Worli Outfall. And I remember about 27 years back, I was lucky to be involved where 70% of ground granulated blast furnace slag was used, with very high limits of durability. Now what is durability? Durability, very simply stated, its coefficient of permeability, water absorption, din permeability, which is depth of penetration, and other factors, all dependent on water binder ratio. When we do concrete today, and why I talk concrete and why I'm passionate even after 38 years on concrete, whether I have worked with Burj Khalifa or the Shanghai Tower or many other projects overseas and in India, is because I think concrete excites many people. When you look at a concrete truck mixer in India particularly, it's not very, very impressive, I know. That's all about the maintenance part. Yeah. But what goes inside the concrete is very important. The hydration, etc. It's very important. Curing is very important. Tests are very important, because only when we are very careful about this. Now look at the wonderful project Bullet Train. Now Bullet Train is a unique project which was obviously, the consultants were Japanese, and every concrete or every construction process adopted there is a piece of unique achievement for Indian, and Indians can do it. Today, I don't know how many of you know that 150 MPa concrete is possible in India, live, and it's produced. You have a 150 MPa concrete, bridge span is about 103 meters, erected in 7 days, precast. And it's all done by Indians. We need to be proud of ourselves. But we also need to be proud of the fact that we follow certain practices which is written in the code and more stringent than the code. If we don't follow that, then we have a challenge. Today, let's say if you have to pump up to 200 meters, how many sites will do a dummy test? You know dummy test, how pump is done. Pumping concrete. You have number of bends, and there is an equation which the pump experts will always say, that if you have 5 bends, you can actually go, and the length is 20 meters for each length before a bend comes, then you could pump actually 100 meters. For Burj Khalifa, there were 14 bends, each of a length of around 40 meters, and I'll show you the picture. It was tested on the ground before it was pumped. So initially they designed it for 400 meters. You think you cannot, we cannot, even I cannot sometimes imagine concrete could have been pumped to 400 meters without a problem. Again, come to India. Anyone heard of Chugachen hydroelectric project in Sikkim? So there was a tunnel lining to be done. And inaccessible for truck mixers, concrete truck mixers. What happened finally was that concrete could be pumped across 2 kilometers on a decline. Concrete to be pumped on a decline is more challenging than incline. And we have so many good examples across in India. So I'll be talking about all of that. And dispersant, so the topic is dispersant polymers. Now what is so important about dispersant polymers? It's very easy to have a polymer. We call them admixture. And wherever you go today, contractors, ready mix companies, pardon me, always say, okay, are you L1? Total cost optimization is never seen. You're talking about, when you talk about total cost optimization, is the speed at which you can pump concrete. It's the technology you use, whether you use for precast. India now is going a big way in the precast. Yeah, in fact, everything in bullet train was almost precast. It's almost 300 kilometers have been finished. Now the next 200 kilometers, 204 kilometers will be built in Maharashtra. Then we are talking about complexity of structures. If you look at structures like Parliament Building, the new NX, all these are about the complexity of design. And why you can put your concrete without blowholes, fair finish concrete. I will show you some examples where high-rise buildings have gone and it's just fair finish with no plastering. You can almost see your face on the wall, it's so shiny. And it is possible to do it if you just adopt certain technologies and certain practices. Then eco-efficiency. Most of the developers in the market, they would love to have green rating. Big houses like ITC, for example, Nestle, whenever they do structures, they always love this green rating. Green rating is a function of concrete and other elements like light, LED, etc. It's about how you also do groundwater harvesting. Concrete is one of the most important elements, and we will explain a little bit about that. This is just to give you how dispersant polymer technology, as you go from height to height, across from Taipei right up to Kingdom Tower, which is 1 kilometer tall. And it's not that there were special concrete technologies from the Western world or not. Some of the projects I can tell you were also handled by people from our country. In terms of the concrete technologists, in terms of the quality control experts, etc. We have Brilliant Tower, which reached a strength of 130, and therefore the spans could be, between the two columns, the spans could have been almost 60 meters, unheard of. Then you have very much in our India, Lodha World 1, where about 13 years back, 95 MPa concrete was achieved. What is the advantage? Slender columns, more FAR. And the span could be as wide as 15 meters, 20 meters to make elegant living as well. So, less water, concrete and cement with tailor-made admixture technology, and this sort of sums up what it is. It reduces concrete consumption because you have slender columns, especially the example of ultra-high strength concrete for a bridge. The section thickness with a 150 mm came down to almost 50%. So look at the weight transfer. And you did not have too many piles resting. You had only, I think the span even for the foundation was around 50 meters. So less concrete again, eco-efficiency. So just to give you an example, everything comes packaged in the molecule. which is about the chain length, the side chain, electrical charges, etc. I think this is all known very well because admixtures now are almost 40 to 50 years in the country. And this is where the molecule it is like a fish bone. Yeah, you have a central bone, just imagine, and you have side bones. And depending upon the design, the manufacturer does, yeah, with the charge center between the spacing, this is what the dispersion effect happens. But it's not only about dispersion. It is also about controlling the mix quality, ease at which the concrete can be mixed, less vibration. You can have a concrete where you vibrate for 15 seconds, then it will spread. Then you have another concrete, 5 seconds, it will spread very easily, no blowholes. When you remove the formwork, you look at fair face concrete. And then there is another concrete where you don't have to vibrate at all. Less labor, less energy. For vibration also requires energy. It requires some sort of fuel to vibrate. It requires people to vibrate. So look at the optimization, because skilled labor in the civil engineering or construction industry, what it used to be 20, 25 years back or even 30 years back, you don't have it today. And construction experts are having a big challenge on the ground. So just to give you how the mechanism goes, the calcium ions of the cement, so this is cement, and then you have this PCE technology. This is the long chain, and these are the innumerable side chains. Design, of course, is based on the manufacturer, and this is what you have. And you know, like charges, when they are coating the cement particles, they repel each other, and that is how you may have more available water for workability. This is very basic. Now, depending upon this, the extension in ultra-high strength concrete where water cement ratio is 0.16 to 0.18. And you can still have good workability. And you can also have good workability at 0.4. You can also have good workability if you add extra water at 0.5, but your durability factor is going to be 0. You will have corrosion problem, carbonation attack, chloride attack. So all of this is a function. So if you see, these are the molecules. This is the cement particle, and basically coating around the cement particles, like charges repel each other, and that's where the available water, which is formed in form of flocks, is available. This is just to give you an idea, because when you tailor, you take into account the water reduction capability, the strength enhancing capability, the viscosity, which is the ease at which you can mix, and the plasticity retention. Today, when we go to ready-mix companies' requirement, especially in the crowded cities like Bangalore, etc., you require 4 to 6 hours slump retention without loss of the quality of concrete, and you do not add water in between the concrete, the transit time. So this is how design happens. Long chain, short chain. So just to give you another picture. So high performance is basically about the low water binder ratio. And for that, we need to have special cultured, tailor-made additives or admixture. And I mentioned about durability. So you can see RCPT, water absorption, depth, and initial surface absorption. 4 main parameters. Considering exposure is extreme or severe, how close it is to the saline conditions or sulfate conditions. Chloride attack is obviously faster than sulfate attack. So when we talk about low carbon SCC, low carbon self-consolidating concrete. Now self-consolidating concrete is basically all about FNR guidelines. You also have it in IS 10262, but they have just copied, cut, paste from the FNR guidelines in terms of flowability, passing ability, and segregation resistance. So, optimizing material usage. That means today I can design a 30 MPa concrete as SCC. It was not possible before. Before, if I had to design 30 MPa concrete, I used to have 600 kg per cubic meter of fines, which is less than 150 micron. Today, I can do it with 450. huge cost saving, because bulk of it is supplementary materials and cement. And this will actually lead to longer lifespan. So this is just to give you an idea about the cost effectiveness versus the flowability. So traditional vibratable concrete, self-compacting concrete, and then this is where low carbon SCC is. And you can design 25, 30, 35, 40 MPa, especially for massive industrial warehouses also. The flooring can be done with fiber, PP, polypropylene fibers, to improve the flexure as well as to improve the crack resistance, because crack is also another phenomena. So just to picturize your traditional concrete, classical SCC and low carbon SCC. You can look at the finish. And these are the various tests. Now today's test, if you look at it, people say, I will deliver SCC to you, or I will provide SCC to you. Half of them don't do passing ability, J-ring, which is very important, because J-ring determines whether your concrete can flow through congested reinforcement. Congested reinforcement, especially when you design 60 MPa to 80 MPa for the columns, thin columns and beams, you need the concrete to flow. It's not only determined on flow, but on passing the space of 37 millimeter, or even sometimes less. So this is why the equipments have been designed. This is just to give you an idea of the qualifying criteria for various, SF1, SF2, VF, whatever parameters you are looking for. So give you an idea about mixed optimization. You see this MPa, 50 MPa double blend, which is basically with only cement and another supplementary material. But you convert this 350 into a triple blend, and I will show you the compressive strength does not change. Even early strength, slightly less, but it picks up, and that is the beauty. If you take 90 days, 180 days, it will be higher. And then you see the durability factor. This is very important. You see the triple blend in terms of 7 days and 28 days, and the water absorption, and the comparison with the control, which is double blend. Tremendous improvement. This is basic of concrete technology extended into high use of supplementary cementitious material. And you have a 44% CO2 savings. This is huge, especially for developers or anyone interested in LEED rating or green building. So give you some examples. This surprisingly is a low cost slum development, because we always think such concrete can only be used in complex structures and all. Bangalore slum rehab, they went for 2 massive housings, and they used this with formwork because they did not have high capital expenditure, so they used only 2 or 3 sets of formwork to roll it out for the entire area. So that is also cost saving, energy saving. Again, on the high end, you have Mahindra Lifespace, also used with low carbon SCC. Then at Orissa, again, these are 2 pictures, one traditional and one with SCC. Then this is in Bangalore. And people from Bangalore will also be very impressed. Yeah. Okay, this is again in Pune. So all across India, low carbon SCC has already been laid. So the other advantage was pump pressure. Now if you've got a very stiff mix, which cannot be pumped but looks very flowable, so when you lift your slum cone, it will creep on the slum board. Now for that you require a high pump pressure. So if you're pumping 50 meters, 100 meters, you will require 200 or 250 bar. You see the reduction by 30% to 150 bar. That means less wear and tear. Less consumption of fuel by the pump, which is also CO2 savings. So if you look at the total cost optimization, using such low carbon SCC is always beneficial. I told you, of course, I cannot see my face on this, but look at the fair face. It prevents repair, which is again a cost and time consuming, and it also gives you a very, very efficient service for the subsequent when the people occupy to paint it or do some putty, etc. Less consumption. This is a machine which is the rheometer, which is used in Mumbai for 80 MPa concrete, and it's a comparison of the shear stress versus shear strain rate. And I give you a simple example for people who may not follow it. You take a pot, put concrete in it. You take a spindle, which you do the dal, you try to just rotate it. The more easy you rotate, the less stress it is. Very simple. No complication. Actually, civil engineering, I thought was very easy. Pothikda will not agree with me, of course. But this is the actual definition if you really want to understand concrete very easily. Because we like to complicate it. People do research, etc. with so many measurements. But I have a very simple way. Yeah, you know dal. You know that you use the spindle to make it uniform. You use that to do the concrete. If it is easy, you don't break your fingers. That's the best mix you can have, as long as it does not segregate, as long as there is no bleeding. Those are, of course, to be taken into account, and it flows very easily. So this is a measurement which was done for 80 MPa concrete, pumped, I think about 180 meters, a very low pump operating pressure. People will be surprised at how 140 bar pressure can be used to pump that. But it is possible, even with difficult aggregates. Today, natural aggregates, very, very difficult to get. With manufactured aggregates or manufactured sand, as we say, or crushed sand, as we say, I know you have to obviously remove the deleterious impurities. But with that also, you can. Do I have some more time? Okay, thank you. So you see, this is what was used even up to 95. This is Lodha World 1. Just to give you an idea about conventional PC versus this same flow, but the time taken to fill it up. So you can see the time difference. This is the rate of flow or rate of ease of flow. So 22 seconds, 11 seconds. That translates into the flow through the concrete pipe, aided by the pump, at whichever level you want to take it. L-box, also a very important thing. You see the flow? No segregation, no bleeding. And on the left side, creeping. Till it comes to a respectable level. And then you measure L1 by L2. I spoke to you about Burj Khalifa. This is very passionate for me because I was very lucky to be involved in this project about 2004, 2005. 824 meter tall structure. You see this foundation? This foundation was about 20,000 cubic meter. Deep piles of around 2.5 meter wide and 50 to 60 meter deep. SCC, no segregation, single pour. But look at the number of bends done here for the trial testing to ensure that it pumps first stage up to 400, because people said that after 400 we need to have another pump. But the mix was so good, it was called soupcrete. And in this soupcrete, it was possible to pump even up to 628 meters. And of course the rheometer was used here as well, just to check what is the stress required for the required strain rate. One more important thing, and this is an IIT building in Tirupati. Why I mention is, We are all talking about finish of concrete, which is also important, because getting the concrete good is all. It has to be placed within the formwork, that when you release the formwork, it should look very good, so that you don't have any blemish, you don't have any bug holes or any porosity, because corrosion, carbonation attack, we know, will bring down the pH level of concrete from 13.5 or 13 to 9.5, where the first stages of corrosion you will notice as reddish or brownish spots. So look at the left, and then you see the next picture with low carbon SEC, using the equipment at site and not running away from the equipment because it is a hazard. Because such tests take a little bit time, 2 minutes, 3 minutes, but it's worthwhile in the long-term total cost optimization. So you look at the finish, fair face concrete, and look at this. This is not a doctored picture. This is actually real life, and it is possible to have concrete without any blemish. It's just a little bit of extra care. Just this last one to just give you how these dispersant polymers work. And this is the cement particle you will see, coated with the different types. This is what happens reality within the concrete, because these admixtures are really invaluable to the quality of concrete. So many people think that, the thicker I make the admixture, the better it is. It has got nothing to do with it. It's all about the chemistry. It's all about the long chain and the short chain, and what type of admixture, what type of polycarboxylate ether. I spoke less about chemistry, because I think you will understand performance better than chemistry. Then of course, it is possible to design different types of tailor-made, whether it is North India, South India, East India, Northeast India, or Chhattisgarh or Bihar, based on the aggregate, things can be done. Thank you very much for your attention. Thank you.
Thank you, Kaur, for giving a very lucid lecture on your low carbon SSC with state-of-art dispersion polymers. Now, if you have any question, you can ask him on this topic. And I'm very happy that this kind of concrete is being produced in India using our technology actually. Any questions?
Yes, today, of course, especially for facades, not for reinforced concrete, but let's say single story and all. I think if you talk about so there is a printer, and the mortar is called the ink. So in olden days, we used to use pen with Sulekha or Quink, and if the ink was not good, then what we used to do is, we used to add little bit of water. This you cannot do in 3D. 3D, the mix preferably has to be pre-packaged, because it is not concrete technology, it is mortar technology, like micro concrete. Yes, yes. So we have this, and we also have a 3D printer established in our technical center. So you're welcome to come to Navi Mumbai and have a look at it. And we have already achieved a height of around 1.5 meter with a thickness of I think 200 millimeter. The idea is to have it to a higher level up to 4 meters, so that you can do one single lift in one stage, because it's self-supporting, right? It does not have any formwork, etc. Today people do furniture, yeah, big flower vases, also houses. Godrej has done a novel example in Pune. It's a house actually, and I think it's also available on the social media when you look for or Google for the pictures. So yes, it is coming up in a big way, but of course cost, everything is about cost, right? So then it only becomes a high-end product or technology. But for facades and all of these high-rises and all, and green areas within land development, I think people are doing it. So India is very much on that road. Yes, sir. Redosing to be avoided. Redosing to be avoided. If you want to redose, you will have to do numerable tests to see where the timing of redosing is. Because when do we do redosing, or when do we do extra water? When the transit mixer is on the road. So it gets stuck in a traffic for no reason. Now if the concrete has already started gelling, then if you use redosing, it will actually be detrimental, because concrete may not set. Then it has to be a different type of a pure super plasticizer.
Because frequent time we are facing this kind of problem at
Yes.
site, where achieving a retention time of even in Calcutta, where achieving 3 hours, 4 hours is very difficult. And so when, as you said, that it is got stuck into the traffic, so sometimes we are abruptly reducing the PCB's plasticizer without having this standard data that what is the regression type of thing is coming. So that's why I'm asking this question.
So it is possible, but then you have to change the admixture slightly. You should have less of retarder.
Okay.
Because again, if you have retarder when you are doing redosing, then that concrete might end up bleeding, or it may not set for that duration. Maybe it will set after 5 hours or 6 hours, but then the client will get anxious that why it is not setting. So
Sir.
redosing can be done, but with a different type.
So I have a question. Myself, Moina Ghoshal from IIC Shibpur, PhD scholar. So smart concrete means interpretation is many types of concrete. SCC can be smart concrete. 3D concrete can be smart concrete. Nano concrete can be smart concrete. So out of all those things, which is the most smartest of the concrete?
Okay, that is a very good question actually.
Yes, sir. Thank you.
See, anything which has a good performance, like a Levi's jeans,
Yeah.
which you are wearing,
Yeah.
is smart, right?
Right.
And then I can wear my suit and say I am smart.
Yeah.
It all depends upon the requirement at that particular time, right?
Uh,
But what is smart? Okay, we're talking, I covered 3 factors, right? Is there environmental saving?
I was late. When I joined, it was on the closing side.
Yeah.
So, yeah.
So we covered environmental saving, which is all about supplementary material use.
Yeah.
We talked about efficiency, like efficiency in pumping, flowability, finishing, and ergonomic. No vibration. That means you require almost 0 manpower. 3E. That's why we call it 3E.
Thank you, sir. Thank you very much.
Thank you. Yes, sir. 1.6.
It was
1.6.
point 0.1 or something like
Point
that.
one
isn't it?
six.
Okay, 0.16. Now, as per Dr. Neville, 1 gram of cement to hydrolyze requires 0.286 grams of water. So how did you come to that
Oh, very good.
0.16?
This is a question I've heard about for last 10 years in different forums, including RILEM in Paris. When we talk about ultra high strength concrete, yeah, so the Japs are like, Japanese people are very good in it. So I learnt my ultra high strength concrete also in Chigasaki. You're talking about a cementitious factor of around 800 to 900, of which 30% is supplementary materials. Then you have microsilica or silica fume. So if you look at the ratio of water to cement is higher. Now some books say 18%, some books say 22%. I have no argument with all the researchers, but I think things have changed and people have gone beyond this 0.18 and 0.22. Otherwise it is not practically possible, because when we see the strength development, if hydration did not take place, then 1 day strength, which is around 65 MPa for these concrete, will not reach 161, right? And if I say that 0.16 is my water binder ratio for 800 kg, which is 128. Now this 128, if I divide by 600, it's 0.2, because that is cement. So water to cement is fulfilling, but water binder is not to be confused with water cement. I hope I have answered. Okay. Yes, sir.
Sir, most of the cases we have seen that to reduce the carbon footprint, we are using SCM, supplementary cementitious material. Mostly I have seen in case of Pune and Western region, 50% GGBS and 50% cements are there and doing the M20 to M25 grades of concrete. They needs the retention, slum retention or workability retention 3 hours. But all cases I have seen that up to some extent workability is being lost drastically. Maybe after 2 hours, even in spite of using any admixture, it is not at all working and quick slammed up. So what is the reason? How can it be overcome?
So it's all about the design of the polymers. So you know the structure, right, of a polymer, because you are a chemist.
Yes.
So you have a long chain and side chain. Now, apart from this long chain, side chain, there are other elements which you can insert within that molecular structure to enhance retention. At the same time, have a very good viscosity. Now, this is possibly 4th generation admixture. The first generation was lignosulfonate, second was naphthalene sulfonate, third was PCE, and the fourth is PCE plus something else. Now manufacturers generally don't disclose it, so I cannot disclose it, but I can tell you that there are other elements between just, you know, what we call I-pegs or H-pegs, which help to enhance the retention. And that is where it has moved to that. Some call it fourth, some call it fifth.
Thank you.
Now I request our next speaker, Sri Bipin Kumar from RVNL.
Service of Engineers. I'm right now on deputation to Rail Vikas Nigam Limited. We are constructing infrastructure in this city and across India, and now we have a presence worldwide.